Hundreds of years ago, navigators found their latitudes using sextants. The sextants measured the angle between the horizon and an object in the sky. Polaris, the North Star, was the object used to measure the angle. As Earth rotates, Polaris's position stays constant, while the angle between Polaris and the horizon varies with latitude. But navigators needed to find a way to make these measurements during the daytime, not just at night. There were charts made that showed the sun's position at known latitudes at specific times of day. By determining the sun's position above the horizon at a specific time of day, navigators could use the charts to help calculate their own latitude, but they needed reliable clocks. Before pocket watches and digital clocks, sailors relied on pendulum clocks, which didn't fare too well at sea. Explorers had to rely on dead reckoning or guesswork, which didn't always work. Navigators at sea could accurately determine their latitude during the day only when marine chronometers were invented in the 1700s. Marine chronometers are precise clocks that account for the movement of the sea and allow navigators to determine the exact time. With chronometers and sextants, navigators sailing around the world could readily determine their latitude by measuring the angle of the sun. Determining longitude was trickier because the Earth spins. Navigators figured out how to find an unknown longitude in the same way time zones are determined, by watching the sunset. If they compared the time of the sunset at their location with the time of the sunset at a known longitude, they could calculate their longitude. They could also do this at night. A star seen in one position by one observer will be seen in the same position by a more western observer at a later time. Today, satellites help us determine latitude and longitude with greater precision. These satellites use the same navigational principles as the early explorers did, but with more advanced technology.